Good morning, dear friends and students. Today we should try to discuss about pericyclic reaction, which is a very important chapter in higher classes. Pericyclic reactions. Pericyclic reaction is a simple game of p orbitals or pi electrons. Pericyclic reactions takes place via concerted mechanism. It means bond formation and bond breaking takes place simultaneously. Now we should try to discuss about property of pericyclic reactions. Pericyclic reaction takes place under thermal and photochemical conditions. It means either in presence of heat or in presence of light. Then pericyclic reaction takes place by a concerted mechanism. It means a very short tension state exists. You can see here, this bond goes here, this bond goes here, and this bond goes here. A short tension state, it means concerted process exists, and after that this whole compound form. It means this bond breaks to form this bond, and this bond breaks to form this bond, and this bond breaks to form this bond. Now we should try to discuss pericyclic reactions takes place via transition state. So you can see here, this is transition state. They do not involve in formation of carbocation, carbanion or free radical. It means there is no involvement of any intermediate. You can see pericyclic reaction takes place via transition state, like this. Pericyclic transition state exists. Pericyclic reaction do not affected by solvent system. It means neither any water system nor organic or inorganic solvent can affect the pericyclic reaction. Generally, pericyclic reaction do not affected by any catalyst. It means catalyst cannot affect the pericyclic reactions. They do not involve in nucleophile or electrophile. It means there is no electrophilic reaction or nucleophilic reaction in pericyclic reactions. They are takes place by thermally or photochemically. Generally, pericyclic reactions are stereo-specific in nature. Stereo-specific means there is only one choice of product form. It means neither any major or minor product, but only one product. There are, first of all, you can try to understand there are two types of reactions in stereochemistry. Means pericyclic reaction involve two types of reactions. First one is stereospecific reactions. It means very specific mechanism is there. It means suppose there is no choice, both it means only one product can form in this process. Suppose in love marriage there is no choice, only they want to form only marriage. It means there is always possibility of only one product. See here, it is like love marriage, only one product form, one mechanism. See here, nucleophile attack, nucleophile RNA species attack here this process, and this nucleophile attached to concerted process and form this one. See in stereo selective process, it is like arranged marriage. See here, one product formed, one is major, another is minor. See here, this is the compound RCS2CS2 CS11CS2. Here is the halo acids. Suppose this is the halo acids. See here, A is the major product and B is the minor product. Two products form. See here, enantiomer selectivity. What is enantiomer selectivity? A plus B form C plus D. C and D both are enantiomer, are two product form. One is major, enantiomer selective, another is minor. See next place. Enantiomers. What are enantiomers? Both in enantiomers, both mirror image. Enantiomer both are mirror image, but not superimposition. E.g. sharpless E symmetric epoxidation, C diastereoselective reactions, minimum 2 chiral carbon atom must present. For diastereoselective reactions, 2 chiral carbon present. First of all, you can understand what are chirals. See here, if this in mid region there is a carbon, here is A, B, C and O groups. If all 4 groups attached to the carbon are different, then that carbon is called chiral carbon. If all are same, then all are 2 are same, then that is not called chiral carbon. For chirality, there is always 4 group attached to that carbon. It means all the valency of carbon should be satisfied by different groups. See here, F, A, B, A, R, this one. Both are diastereomers. See here, A, B, R. This one is same, A and A. See here, D, F, E. See here, this is different. One chiral carbon is there, one chiral carbon is there. Regioselectivity. What are the regioselectivity? That means in regioselectivity they are the structural isomers. A plus B form C plus D. In regioselective reactions, there is always formation of one product. They are stereoisomers. Suppose this compound react with hydrochloric acid to form this one. This is not formed because there is always possibility of one product, that is the 100%. It means in regioselective process there is the formation of always single product, that is a regiospecific in nature. What are the chemoselectivity? Chemoselectivity is the property of reagent. It means chemical selection. Here in this process the reagent select particular reaction chemically. Suppose this is the ketone group like this one, and this is the ester group. Lithium aluminum react with this to form select this group, this ketonic group chemically, and form OH and OH. This is called chemoselectivity. Conductor of alcohol. This lithium aluminum hydride is very important. It always keep OH with the ketone or ester, COE group. So it is called conductor of alcohol. Very important. It means when LiLS4 is present, then always possibility of formation of alcohol. But when a mild base NaBH4 is present, then there is a possibility of alcohol and it remains as such, like this one. types of pericyclic reactions. Pericyclic reactions are of three types. One is electrocyclic reaction. Pericyclic reaction are generally four types. First one is electrocyclic reaction, second one is cycloreaction reaction, third one is sigmotropic reaction, and fourth one is a group transfer reaction. Actually, group transfer reaction is not a type of reaction, but it involves a reaction. First of all, we should try to discuss about electrocyclic reactions. It involves intramolecular cyclization of conjugated polyene under thermal photochemical conditions. See here, in presence of heat or light, this bond breaks, and this bond breaks from this one through a tension state and form cyclobutene. Electrocyclic reaction takes place in a single molecule. See here, this bond goes here, this bond goes here, and this one goes here. A short transition state for a fraction of a second takes place and form this compound. Cycloreaction reaction, it involves the combination of the two unsaturated moieties in benzene species and formation of cyclic structure under thermal or photochemical conditions. Cycloreaction reaction are of two types. First one is intramolecular cycloreaction reaction. Second one is intermolecular cycloreaction reaction. Intermolecular cycloreaction reaction, this one and this one, for in presence of photochemical light. This is called 2+2 cycloreaction reaction, and this is the transition state and form this compound. Total number of 5 electrons present in both species is 1 and 2. In intermolecular addition reaction, cycloreaction takes place in a single group. In pericyclic reactions, the direction of arrow is always same. Sigmotropic reactions. It involves migration of sigma bond or pi bond. See here, this is the group CS2 CS double bond CS2 whole N. When N is equal to 1, then CS2 double bond CS, this CH goes to here, and for this one CS2 CS2. So here you have to explanation of pericyclic reactions. There are three theories for explanation of pericyclic reaction. One is diaphragm approach or frontier molecular orbital approach. Second one is Devers PMO approach or perturbation molecular orbital theory. Third one is electronic configuration of same molecule. Okay, so discuss it in next video. Okay, thank you.